Hello, everyone. Welcome to our webinar today. So the subject of our webinar today is going to be powerful features of GRAITEC Advanced Design for your specific projects. My name is Farshad Pourshargh. I am the Technical Solution Manager for GRAITEC US and Canada. So let's go on with our subjects today. So I'm going to give you an overview of the subjects that we will talk today. So I would like to first go through advanced design. So what is advanced design? What kind of features and tools we have there for your usage? It's going to be a short introduction. Then we have three special features in advanced design to help you with your modeling and design and in your projects. So the first one is going to be concrete design and detailing modules in advanced design. Then we will talk about the stage construction tools. And finally, the nonlinear analysis tools and how you can actually perform nonlinear analysis in GRAITEC Advanced Design. So what is advanced design? Just to give you an overview, advanced design is a full 3D finite element solution. So you can model different types of structures, 3D frames, or even plate and shell elements, different kinds of geometries in advanced design. Also, it does code check and verification based on most of international standards and codes, as well annexes. You can have multi-material modeling and analysis in advanced design. So it doesn't matter if your structure has steel, concrete, timber, etc. You can actually have a geometry that you can mix all of those kind of materials inside your project. In advanced design, we have automatic load generators specifically for snow and wind. Based on the base values that you will define in the software, advanced design is able to generate the automatic wind and snow loads on your structure. We have a simple modeling tool in advanced design. So basically modeling and creating the geometry in advanced design is much more simpler. So we don't have the concept of nodes or points. It's just like a CAD solutions software. So you can just draw your elements, copy them, extend them, and even trim them, etc. So the modeling is much more easier in advanced design. It comes with a powerful mesh engine. So defining your mesh on specific geometry is easier in advanced design. We also have specific tools in advanced design for the mesh engine that you can also localize the mesh. If you want to refine the mesh in specific parts of your structure or elements, you can also do mesh refinement easily in advanced design. The other benefit is our BIM workflow in advanced design, which works very good with Autodesk Revit and advanced steel. So in case of any type of structure like steel or concrete, you can always create the geometry inside Revit or advanced steel and send it to advanced design to perform your structural analysis. Concrete rebar placement and design tools, which is actually one of the subjects of our webinar today, and we will go through it during this webinar. We have steel section optimization. So in terms of steel design, we have a tool in advanced design that it can also optimize your section. So based on the criteria that you will define, let's say over 100% of workload ratio or less than 50% to optimize your sections, you can define those parameters in advanced design and software will automatically optimize your sections. Beside that, we have nonlinear analysis, pushover analysis, and even more other types of analysis and features in advanced design that we can go even more into detail later on. So here's I have put some screenshots here. So this is basically the workflow of advanced design between Revit and advanced steel. So as you see, the workflow can work both ways. So you can either start from Revit or advanced steel, send your model through GTCX to advanced design, apply your loads, perform your analysis and code check, and then you can send it back to a Revit or advanced steel using our synchronization mechanism. So the synchronization mechanism, it works like if you have changed something in advanced design, like let's say a section or something in geometry of the structure, the synchronization tool will automatically detect that when you're exporting it back to Revit, let's say, and it will warn you about that changes, and you will have the option to check all of the changes. You can have accept them, you can or ignore them. Here also we have types of codes that we have in advanced design. So obviously we also have Euro codes, but here I have put some screenshots from US codes and Canadian codes that you can select, and we have all of them for you to use basically in your projects. Here I put some kind of complicated geometries and results here on how advanced design looks, and the model will look in that. So we have a 3D full rendering graphics in advanced design that you can basically rotate, pan, etc. And as well, same options for our results. So it's going to be fully color mapped. As well, you can also have the values of diagrams and deformation, etc. In your results display. Here I have a screenshot of the automatic generated wind load on an open transmission line tower that in advanced design we have this tool. So you can automatically generate this wind load on open structures in advanced design. We also cover time history analysis, as you see here. So I can input my basically time history acceleration curve and perform my time history analysis in advanced design. And as well here, as you see, this is an example of automatically generated snow load, actually on a kind of complicated geometry. So you won't need to do it manually. As you see, we have tools in advanced design to create those kind of loads. So what are the main benefits of our concrete design and detailing module in advanced design? So this is the first subject of our webinar today. So the main benefits are the design and detailing of concrete, or the module that we will use to perform those actions. It's directly inside the same package. So you don't need to install another package or have a link between two solutions or two windows. So it's going to be exactly on the same solution. You don't need to install, as I mentioned, extra modules. This module works for beams, columns, foundation, slabs, and as well walls. So basically most of the elements that you will see in your projects. The forces or internal forces that have been calculated in a finite element solution will be automatically transferred to detailing tool. So basically we are detailing our elements based on the forces that we calculated from the finite element analysis. As well, the other benefit here is this module also can be installed directly on Autodesk Revit. So we call it Power Pack. So in case if you want to use the module as well on Autodesk Revit, it's an add-on that we can just plug in onto Revit as a Power Pack, and you can use it exactly same as advanced design. So it will also help the Revit users as well. So here I have an example of a concrete structure. So this is the geometry of a concrete structure in advanced design. So as you see, I have different types of structural elements in this structure. So we have foundations, beams, columns, slabs with openings, and as well some shear walls there. So after performing our analysis and concrete design, first advanced design will provide us with required rebar area or area of steel in each element, as you see here, down there. And even for this is going to be for beams and columns, basically one-dimensional elements. And also we will have our required rebar area for planar elements like slab roofs and etc. or walls. So these are going to be based on the concrete design module that we have in advanced design. So what we can do with these numbers or results, well, we have two options here. First can be like taking those numbers and providing or detailing our sections manually based on the required areas. But the benefit of concrete design modules is going to come here in my next slide here. So for example, in advanced design, this is a slide that I'm showing to you here is about foundations. So basically in advanced design, just with clicking on your support in your geometry, the concrete module of advanced design will be opened automatically. And here we will have the option to basically detail and design the rebars inside my foundation. So as you see here, you can also define the soil properties of the foundation because as you see down here, Advanced Design can also do and perform not only the concrete design checks on your foundation, as well the stability checks. Okay, so overturning moments, etc., resisting moments, as well the stress distribution on the foundation. So you can get all of those results from our design modules. And as you see here, all of the forces like axial, shear, moment, torsion, etc., will be automatically transferred to our design modules to perform this kind of design. So here in this slide, as you see, it is not just a 3D view. In some cases, if you want or you need to have also drawings of those rebar placement and concrete design, again, in the same module, you can also create drawings. So as you see here, this is an example of the same foundation that we discussed earlier. And you see I have my cross sections, plan view, and column section, and the rebars inside them as drawings. And more interestingly, Advanced Design can also create the bar schedules for you. So with bar shapes, total length, total weight of rebars, etc., which, as you know, like it can be somehow difficult to create these bar schedules. But here in Advanced Design, we create them automatically for you. So here is another example of a beam actually design, which is the basically same scenario, okay, as foundations. So you just select your beam from your 3D structure that you have in Advanced Design. Just click on that, and now you can open it in our rebar detailing module. And as you see, you can put the rebars there. You see the rebars. It's going to be actually automatically defined for you. And I have my cross section and a 3D view of my rebars. And down there, Advanced Design is also able to provide you with some design results. Okay, so what is the theoretical required rebars? What's the provided rebar? What kind of stresses we have in concrete? So all of those also, we have specific tables in Advanced Design, as you see here, in case if you want to investigate the results and how Advanced Design calculated those rebars for your elements. So here is another example, again, coming from the same structure, but this is a shear wall design. So as you see here, we have the option in Advanced Design that you can either do a design of just singular shear walls or group of shear walls. In this case, I have selected a group of shear walls element here. And as you see, I have the 3D view and also plan view of my rebar detailing inside this shear wall. For the slab design, we have also two methods in Advanced Design. So you can do slab detailing and design using the rebars in Advanced Design using two methods. The first one is going to be based on direct areas calculated from finite element analysis. Also, we have the strip method that, as you see here in this screenshot, Advanced Design will automatically create the strips. And after that, it will calculate the moment and axial force, etc., that each strip can have. After that, it will automatically turn those values based on the strip method to rebars, as you see here. So this is the rebars that generated for this slab. And as you see, software will automatically detect all of our openings and put specific rebars around the openings. And down below here, same as the other components that we discussed, we can also create the drawings of this floor slab and as well the bar schedule. So as we discussed, Advanced Design can automatically create those rebars for you in those elements. But what if you want to change something? Okay, let's say if you want to modify the column section, if you want to modify the thickness of foundation, even if you want to modify the rebar diameter, etc. So we have also that option there. So after you perform the design, you can always go to different windows and tools that we have in Advanced Design to just go and change those rebars based on your preference, okay? So let's say if the concrete area of my column is not enough, we can directly also change it here in the design tool. And let's make a bigger column and redo the analysis and perform the rebar placement again and recheck and verify if the member passes the checks. And same thing for foundations. Basically, you have full control on the foundation geometry as well. These modules that we talked, they are flexible. So as I mentioned earlier, these concrete modules that you saw here, they can be also used on Revit, which is called power packs. Power packs that we have in Revit for these modules, they can work basically in two ways. So first way can be you can import your analysis results from advanced design inside Revit and use these tools to generate your rebars. That's one option. The second option is if you are not using a structural analysis software, but you have the internal forces manually calculated or from other software, you can manually define those forces inside Revit using the Power Pack, and Power Pack will use those forces to basically generate your rebars. The rebar areas also will be also imported inside Revit using our BIM workflow, in case if you're interested in that. Detailing and design will be based on finite element calculations if you're importing them from advanced design. The format that we use is a GTCX format. It's a GRAITEC specific format. The main benefit of this format is it is much more compatible with Autodesk Universe. As well, it can transfer your internal forces and rebar areas inside Revit much more easier. Basically, in our Revit Power Packs as well, we can do beams, columns, foundations, slabs, and walls. So similar to advanced design. This time, you can do your drawings and bar schedules directly in Revit using the Revit native tools. And as well, we have specific tools in our Power Packs that you can modify or customize the rebars generated using the Power Pack, okay? Our Revit Power Pack also comes with other tools that it can help you. I'm talking about like Revit usage. So for example, as you know, in Revit, we also have an analytical model. So sometimes the analytical model, maybe it's not very suitable to be exported to a structural analysis solution. Let's say you have discontinuities or eccentricities, etc. So in Power Pack for Revit, we also have some tools that they can help you to fix your analytical model basically in Revit. So it's going to be ready to be sent to any structural analysis solution. So here I have some screenshots of that tool. So basically this is the Revit main tool, as you see here, but our Power Pack design will be basically installed as a Power Pack here. It's going to be a separate menu with different tools. So as you see here, you have two options to import your loads. Either you can apply them manually, or you can actually import them, as you see here, import analysis results from advanced design to perform your code check and rebar detailing inside Revit. And as you see here, both types of results, either internal static forces, also required reinforcements, will come in directly from advanced design. Here at the bottom picture here, you see that I have imported my forces, and in Revit I can also study them. So here is a diagram of my actual forces inside each column that you can study them and just compare them with your maybe hand calculation or compare them with advanced design. And when you're sure that the internal forces are correct, then you can use our Power Pack to perform your rebar detailing inside Revit. So here is also an example that now I'm using Revit to define my rebars inside this column and foundation. You just need to select that element, click on calculate, and the tool Power Pack will automatically calculate those rebars inside your elements. In terms of exporting, importing, and synchronization, we have a Beam Connect tool, which is going to be again installed on the Power Pack. And using that tool, you can basically export the full structure inside Advanced Design. You can import the structure from Advanced Design, and you can do synchronization, which is going to be including all of the changes that you have done in Advanced Design for your structure. So that was a brief overview of our concrete modules on Advanced Design. The second subject of our webinar today, it's going to be for the staged construction in Advanced Design and how to use basically this feature. In what scenarios you can use this feature? So it's going to be basically will be on the type of construction or geometry that you are using. So as you know, like in traditional method of structural analysis, we model the structure fully. So as it's built completely, and then we apply all of our forces, etc., to study the structure. And then as well, we apply all of the loads to the complete stage of structure, to last stage of structure. But in practice, as you know, structures are constructed in stages, you know, so let's say first story, second story, etc. And as you know, when we are creating these stories or level or stages, at each stage, some loads and finishing loads will be present in that stage as well. So the other important point here is, especially for concrete structures, the behavior of material can change while you're doing these stages. Okay, so you pour your concrete for the first stage, and you continue on second or third stages or other portions of structure. So the material behavior of concrete, time-based deformation, and modules of elasticity, etc., can change. So when we are doing a structure as a full structure, like the complete, we are not considering those kind of changes in the first stages that it happened. In some scenarios, some projects, you may have elements that they need to be removed or added during the stages, okay? So maybe you have an element that at the final stage of the structure, completed structure, it is not there. But at some point in some stages, it was there. So that's also another usage that you can use stage construction to model those kind of behavior. The stage construction can be also useful for retrofitting projects, you know, on existing structures. So you can add and remove extra elements while the structure itself is under loads, okay? As well, the final one that stage construction can be used is possible change of support conditions during each stage of basically your construction. So here I have an example of a transfer beam scenario here. So basically, what normally or in traditional way we would do is we model the structure like that. So this is the full structure. I create the full geometry, and we apply our forces to that structure. But in reality, probably based on the structure, maybe it's been created like these stages. So first we have the first story, and we have just a beam, which is not supported. It's just supported in two ends, and it's under a self-weight. Then we add the second story, and now I have another column which is applying forces on that beam. And then we continue on. So behavior of each stage here can be different than what I have if I modeled this structure completely, okay? So that's how we can use this stage construction tool. So we can go stage by step, and advanced design in each step will calculate the deformation, internal forces on that, and then we can go on and check everything. So basically, what I mean here is, let's say the moment or deformation or internal forces of this beam can be different if we are doing it based on stages than if we are doing it like this with the complete structure created from the beginning. So another maybe example here. So this is a backfilling example. So it can be also a subject of stage construction. So as you see here, based on your project, you may you are applying your lateral pressure of soil on the walls before putting the slab or after putting the slab. So in this case, again, the behavior that you will have in the walls and internal forces in members, etc., will be different. So probably in this case also we can use a stage construction. So in the first stage of construction, I can have my walls, I can apply my lateral load pressure from the soil, and then in the next stage I can add my floors that to exactly capture the real forces that they are happening while we are defining this extra slab. Another example, again, from stage construction. So this can be like an example of adding a column to structure, okay? So let's say at the first stage, we have this structure here. Again, it's under loads and deformation. And in the second stage, we are adding a column to the structure. Okay, so again, if we just start from this last stage here, the internal forces and deformation would be different than what this structure has experienced when we didn't have those columns defined. The way that we define stages in advanced design is simple. Basically, we have a menu entry here, which is called construction stages. You can create as many as you would like, just clicking with plus sign here, and stages will be created automatically. And then you will have the option for each element or even load in advanced design that you can add them in specific stages, you can remove them, and you can have other decisions here as well. So if you want that load to be present in all of the stages, you can select this option to have it added in all of the stages of structure. So let's talk a bit about nonlinear analysis in advanced design, which is the third subject of our webinar today. So basically, nonlinear analysis, we have linear or nonlinear analysis, as you know, basically these are like methods of calculating the internal forces, moments, even deformations in the structure. So as you know, in linear analysis, we only assume the initial geometry of the structure. So we assume that the structure has not deformed under the loads. But in nonlinear analysis, we consider that it is a deformation which has happened in the structure. So the extra loads that we are adding, it's being applied on a deformed shape of structure. This is also called like second order effect. And what's going to be effect is going to be, it can have higher forces in your elements, okay, because of the deformed shape of the structure. We have basically several types of nonlinearity. So we have geometrical nonlinearity and we have the material nonlinearity, which is going to be based on properties and stress strain curve of your material. So for example, another example of material nonlinearity can be applied as plastic hinges when you're doing pushover analysis to your structure, which we have it in advanced design. And as well, like other types of nonlinearity, as I mentioned earlier, it's going to be the geometrical nonlinearity that we also can cover that in advanced design. So here is an example of a geometrical nonlinearity. We call it P delta effect. So as you see here, if we assume that it's a linear analysis, basically, we assume that this column top has not deformed because of this lateral force. So if we assume that and assume that it's going to be the initial geometry of the column, the moment that we have at the bottom here, it's going to be this value. So basically V times H. But in a nonlinear analysis, as you see here, we will include this delta or deformed shape of top of the column. And as you see, this is going to create even more moment, which is a P delta effect. And my column will end up having higher moments at the bottom. Same example basically here in a 2D frame. So if I use linear analysis, let's say my moment values is going to be less than when I am actually using the deformed shape of structure. Again, that's going to be because of the extra moments that are created because of my deformed shape and the nonlinear analysis. The other example of nonlinear analysis can be for large deformations. So mostly used in cable structures when you have cable elements. As you know, cables has a tendency to have very large deformations. So in some cases, some software, they're not able to converge based on those large deformations. So in advanced design, we have specific cable elements and as well large deformation analysis that you can just basically assign those cable elements to these members there. And using the large deformation nonlinear analysis in advanced design, software will be able to converge the results and you will have your internal forces correctly calculated inside the cables as well as the deformed shape of those elements. Basically, the way that we define nonlinear analysis in advanced design, again, we have a dialog box as you see here there, as you see it here. So you have the control on number of steps, number of iterations, which iterations you want to save those results. As you know, like the nonlinear analysis is always like step by step, and in each step we have different iterations to converge. So you can either just save the latest, the last step, or you can actually, if you want to study the full behavior of structure during load application, you can use an option we have here, which is going to be save basically the results in every step. So it's going to be an iterative process. Software will iterate inside those steps to converge and provide results for us. Convergence criteria is force, displacements, and energy. And as you see here, we have different methods like Newton-Raphson method to achieve that convergence. So the other type of nonlinear analysis in advanced design is pushover analysis. This is a mix of material and geometrical nonlinearity. So we basically consider both of them. So pushover is a static nonlinear analysis, mostly for lateral forces. And how it works is we basically, based on a lateral force pattern, mostly seismic forces, we apply to the structure laterally. And we study the structure in each stage to see what's the behavior of structure, okay? So, and basically the force deformation curve would be something like that. So basically at some point when we have small deformations, structure can take forces, but at some point the joints become plastic, the structure cannot take higher forces. So at some point we will basically arrive to the capacity of the structure at some specific deformation. So the point of pushover analysis is to calculate this behavior and see what exactly is happening inside my structure. So in advanced design, we have several options to define pushover loads. So first of all, you can have different types of load distribution, lateral load distribution, basically on the structure. So we can have uniform, triangular, and also parabolic, as you see here. In advanced design, this is a window where you can define basically those forces. As well, we have the option, if you want to define a manual distribution yourself, you can do it as well in advanced design. And you can apply that pushover force in any direction, X positive, negative, or Y directions to study the behavior of structure. So how it works, basically, we define plastic hinges in critical locations in our elements, mainly columns and beams. And as you see here, these hinges will work like a special rotational spring in terms of columns and beams, or as nonlinear axial springs in terms of bracing elements. And the behavior of these hinges are fully nonlinear, as you see here, some examples. So at some point they are fully elastic and then they become plastic. And after that, even we have a drop down point. That's the place that my hinge take any more forces, or it doesn't have any capacity to take moments. Basically, it becomes a hinge. So basically, this is the idea behind pushover analysis and hinge definition, basically in advanced design. So to define these plastic hinges in advanced design, we go to member properties, basically, and we have parameters here that you can assign different types of plastic hinge behavior to your members in different locations. And as well, we have a standard hinge behavior, which is coming from special codes, or also user can define customized hinge behavior in advanced design, as you see here, based on your moment and rotational values that you get from your section. Results of pushover analysis, basically, it's going to be like the deformation of a structure. So you can actually check the deformation and internal forces of the structure under different push steps. Finally, the other output is going to be what we call pushover curve. So here I can see the behavior of a structure starting from elastic range, place that we don't have any plastic hinges yet, up to the elastoplastic or plastic range that most of my structure or hinges has become plastic. So is there a way to study the behavior of each hinge separately to see at what stage my hinge became plastic? Yes, that's the other results of pushover analysis that we have in advanced design. And as you see here, I can go again step by step and study in which location of my structure I am developing some plastic hinges and what's the status there, because each plastic hinge can have different statuses that we can see in advanced design. And at some point, as you see here, depending on the hinges or where we are going to put the hinges on column ends or beam ends, we can have different behavior from hinges. But again, that can be captured in advanced design as well. Okay, so thank you very much for your time. I tried to be brief on those subjects. Obviously, there can be like so many things to discuss on those. But again, I tried to keep it short here just to give you an idea of what kind of advanced features we have in advanced design for your usage. So for any kind of questions or information, you can always contact us, support.us@GRAITEC.com. and support.canada@GRAITEC.com. As well, you see my note there, so you can always let us know what kind of subjects you would prefer, so we can explore in advanced design. We can have extra webinars on those subjects, so to be more informative and give you more information on what you really need and looking for.